is what I'd like you to do from here is pause the video and try out this example. Now that we've tried it out, let's take a look at this in terms of the law of sines here actually first and see why we can't use it again. So you can see we have actually all three of the side lengths this time, but again, we don't have any corresponding angles. So what that means is we're really forced to use law of cosines here. And so let's think about which one we want to use. Well, since we don't know any of the angles, but we know all the sides, it means that we can actually use any of the three formulas for the law of cosines. My recommendation on which angle to find, though, would be this one here. Okay. Reason being, you may have remembered in the last example, we talked about how sine inverse is only going to give you angles between minus 90 and 90. So this meant that using law of sines wasn't good for finding obtuse angles. But remember, cosine inverse, it can actually give you angles between 0 and 180. So it can actually, let me write that correctly, we can actually get obtuse angles if we're working with the law of cosines. So that's what we're going to do. We're going to use law of cosines to find angle B first. So it ends up we actually want to use the same formula here again. B squared is equal to A squared plus C squared minus 2AC times cosine of B. And we know that B squared here is going to be 16 squared here. And then A squared, so let's see, which one is A? Well, opposite of angle A is side A, so we have 10 squared here. And then opposite of angle C should be side C. So then we have plus 8 squared. And then minus 2 times A times C. And then cosine of B. And so our goal here is to solve for this angle B here. And so if we were to square these three terms that are squared and move them all to one side, we're going to get 92. And if we multiply this stuff here together, that's minus 160. Then we have cosine of B. And then from here, we could divide each side by minus 160. And if you do that, you get 92 over minus 160, which will reduce to minus 23 over 40. And then finally, we'll take cosine inverse of each side. We get B is equal to cosine inverse of minus 23 over 40. And as long as your calculator is in degrees, you will get an obtuse angle, which is what we were expecting here for B. Okay. But if we go ahead and round this to the nearest degree, this is going to come out to 125. But I'm going to do the same thing here that we did on the last example. I'm going to store this in my calculator so I don't lose my accuracy here. Let's just note that this was in degrees. Now, the nice thing is here is now I can use law of sines. And I like to use law of sines over law of cosines because it's a little easier to use. Okay. And we have no worries about using law of sines now because the remaining angles here are acute angles, not obtuse angles. So let's maybe find, how about angle A? So if we do that, we can set up our equation. And we know angle B. We know that side length B is right here, which is 16. And then this is equal to sine of angle A over side A, which is 10. But just remember, even though it looks like there's two variables in this equation, this B here is stored on our calculator. You don't have to write this every time. I'll know that you have it stored in your calculator. And then next, again, we want to solve for angle A. So how about we multiply each side by 10? It gives us 10 sine of B over 16 is equal to sine of A, which then tells us that A should be equal to sine inverse of this left-hand side here. And you can actually reduce the fractions on that left-hand side. 10 over 16, we could rewrite that as 5 sine of B over 8. So I just divided the 10 by 2 and the 16 by 2. So if we plug this into our calculator, we should get about 31 degrees. And the only thing we have left here to find is the angle C. Right, the angle C. So we should just be able to do 180 minus these two angles that we have here. And if we have those stored in our calculator, angles A and angles B, then this is just 180 minus A minus B, and this should come out to about 24 degrees. Example 2, a plane leaves airport A and travels 540 miles to airport B on a bearing of north 34 degrees east. I'd like us to start off by just sketching that, and then we'll read the rest of this here in a minute. Okay. So let's put a point down here somewhere. Let's call this airport A. And we want to travel north 34 degrees east. So you want to think actually about your north line here for a second. And the idea is we want to rotate 34 degrees towards the east for our angle that we're about to sketch here. So that should look something like, let me actually use the line tool here. So now we're to airport B here, and we're told then the plane later leaves airport B and travels to airport C 410 miles away on a bearing south 71 degrees east. Okay. And we were given a distance on the other one too. It was 540 miles. Let me write that a little nicer. 540. Okay. So this next bearing that we're going to take, again, is from airport B, and we're told that it's south 71 degrees towards the east. So that would mean that we'd want to rotate 71 degrees towards the east, and this was from the south. Okay. So if we do that, that looks like that should maybe be something like this. And we shouldn't go quite as far because this is only supposed to go 410 miles. There we go. Now let's read the rest of this question. Find the distance from airport A to airport C to the nearest tenth of a mile. So what we really want to look at is just what is this length here from here to here. Distance from A to C. Well, we see that we have these two sides here, which is great, and we want to find this one. Okay. And let's go ahead and label this one as side B. Now, if we want to find side B and we have sides A and side C, The only other thing we need to have in order to find this side here is the angle B. Well, we knew that this was 71 degrees towards the east from the south line. And the question is, well, can we figure out what angle would go here? Well, notice you have two parallel lines, right? These dotted lines are parallel, aren't they? And then you have this line that's 540 miles long intersecting both of those. And so what that means is, well, we already knew this angle was 34. That means that this angle should be 34. And so what that tells us then is now we do know the angle B. Okay. Should be both of these two combined here, which is 105 degrees. All right, we have everything we need now. Let's go ahead and write down our formula. It's b squared is equal to a squared plus c squared minus 2ac times cosine of big B. And so little b we don't know. Little a, that's 410, so we have 410 squared. And then c is 540, so we have 540 squared, minus 2a c cosine of b, which is 105. And from here, we'll go ahead and we'll compute all this, and we'll take the square root of each side, right? So we just really need to plug this right here into our calculator. And if we do that, so what we get is we get B is approximately 757.8 miles. And we're done.